Okay, folks, this is a short video, more of a reminder on what we're doing when we're doing hypothesis testing. I have as my background part of a book, which I talked about in the earlier videos, but here's the book right here, Statistics for Dummies. Um, you may not like everything about that title, but it really is a very good book, and I highly recommend it. Um, They do a good job of explaining a lot of the procedures in this class using other words and things that language that may be a little bit better understood. But anyway, I want to do a little review on hypothesis testing. Maybe this will help you out. So really, what are we doing when we're doing a hypothesis test? What we're doing is we're challenging a claim that's made in the culture or that we hear about. We're thinking, um, we got to figure out what I'm saying here, what I wrote. Um, we're thinking about what is commonly believed, and we're believing it's not true. We believe that somehow we have evidence against this claim, whatever the claim is. And so we formed this opinion, and we are, um, wanting to know what we could do about it. Perhaps it's something like what is defined as being overweight. Uh, it could be the time spent on a smartphone and how much time is okay, what's too much. It could be about what is that unemployment rate in our country. That's the figure I believe I'd like to know, and I'd like to know how that's figured out. Another one will be effective pain reliever. Is Advil the best pain reliever? What about ibuprofen? Um, I would like to know some more information about it. What dosage is the limit, for me to have, uh, and that sort of thing. How about my car? Uh, my particular brand of car. What's the average MPG for folks driving that car, and what is mine? How does that compare? How does that compare with the best mileage vehicles? That's a good question. Another thing would be about my car is its reliability. What's the longevity of the car? How long will it last? That's a good question. Or it could be that we see a commercial on TV about some new drug and it promises to treat this particular condition, and we have that condition and we want to know more about it. Is it really effective? Or it could be that there's some new medical procedure out there to treat some type of condition, and you want to know, is this something that I should do? Should I get sinus surgery? Should I use um, spray up my nose? Or, there are a lot of things that we are wanting to know about concerning our health or diseases, and there's a lot of information out there. So that's the reason why we need to be aware of the um, environment surrounding hypothesis tests. So what happens? Well, there's studies that are out there. There's product testing, and then there's some type of final report that you see on the news or in a magazine. It could be, what is the latest finding on the unemployment rate? What about all this stuff about global warming and the science behind it and the records and the data? That's still a little foggy in our culture. So now let's do this. We want to challenge a claim and we want to conduct a hypothesis test. And so, what is the basic method? Well, number one, we want to be scientific and we want to try not to be biased so that people could believe our results. Here are the steps in our hypothesis testing. Number one, we need to state our claim. All right. What is the statistic that is being believed in the culture, currently accepted? It could be the average of something. It could be a proportion of people that hold maybe have a condition or whatever it is. It's some population parameter or population value. Next, we need to write down what is our challenge. So the first is called the null hypothesis, and then we're going to come up with the alternative hypothesis, and we're going to do some research. Matter of fact, sometimes this is called the research hypothesis. We're believing that what is claimed is not true, that that value is actually less than that amount, or that the value is more than that amount, or we just want to say that value is not true. So we need to write out our challenge. And then we need to gather some information. So we need to do some type of experiment. In this case, normally it's finding a sample and gathering that data. So we conduct a collection of data. Then what we need to do is we take our data together. The fourth step, we calculate the statistics. So again, we don't have everything about the population. If we had that, then we would know what these values are, right? We would know that the claim is true. Most of the time we don't have that information, so we're looking at a good sample. Remember, it has to be a random sample. So we calculate all of our numbers, and then the next step, we compare our findings against a standard normal way of determining a value. Now I should say that another way. We want to determine the p-value of our test statistic. Is this really odd? Is it further than 2 standard deviations away from the claimed value? That's a good question. So our p-value tells us how far away from the claimed value our sample statistic is. Now remember, we're assuming it's going to be pretty close to it because that's what is commonly believed. And then number 6, after we do that comparison, we either accept or reject the null hypothesis. If we accept the null hypothesis, then we didn't have enough evidence, or our p-value was big. And so we go, well, what was commonly believed is pretty true, or at least it is in this case right now. Or the other thing that we could do is we could reject the null hypothesis, which we're saying based upon our research, we found that what is claimed is not true. And we're going to reject that claim and say that whatever value, the average of some particular measure is not right. It's less, or it's more, or it's not equal to. And so what we do is we use our alpha level of significance, either 0.05 or 0.01. And of course, we compared our p-value. If p is less than the alpha value, then we can reject. If p is greater than the alpha value, we don't have enough evidence. And of course, there's a middle of the line approach there where it's very close, and we have to use our good judgment. And keep in mind that when you reject a well-established null hypothesis and you have challenged a claim, you create a lot of interest in others wanting to do their own research and verify that. So it could be a very good situation to direct people's interest in verifying that for themselves. And then the last step is you want to write a conclusion. Try to be not too technical, but you're going to say, we have rejected our claim and we are claiming that such and such is actually less than such and such. And you can even include your level of confidence. So you want to report that. And as we know, not everything is reported accurately. And in the reports to the media, not everything is included. Not all of the data is included. So if you are wanting to know more, you have to research it. Just because you have a nice commercial and the graphics are good and people feel good about themselves and say all nice flowing things, it really doesn't mean much in the truth value of what you're trying to get across. Okay, enough said there. Then we need to finish up our discussion talking about two types of errors. Of course, the one error is the type 1 error, or what I call a false alarm. So a false alarm is what was believed is still true. In other words, you challenged it and you made a mistake. You rejected the null hypothesis when really it is true. So we'll call that a false alarm. Hey, the car alarm went off, okay? But no, there's not a problem with it. It just went off. So again, that's a type 1 error. And then you can make a type 2 error. And type 2 error would be missed detection. That would be the way I would characterize that. What do we mean by that? Well, the claim really is not true. You know, it's not true that the Earth is getting so hot we're going to have to desperately soak a bunch of money into having everybody not use electricity or whatever. Okay. So I call this the misdetection. Claim is really not true. We failed to reject the null hypothesis when you had good evidence. So you have evidence to claim that there really is a difference in whatever measure you're making, and you missed that. I remember this one by thinking about type 2 diabetes and getting tested and me actually having it, and the doctor reporting, no, you don't have type 2 diabetes. And I think many of us can relate to that. So those are two errors that you can make, and it's important when you are doing problems in the exercise, then you're answering the question on the quiz, that you understand how, what the question is asking, and that you understand the answer choices. Maybe this little short video will be a good reminder for you on that. So again, I wish you well as we finish up with this last Unit 4, and good luck on this Unit 4 exam. Thank you.